Hello. So I am Josh Pyorre. I am a security researcher at OpenDNS, which is now purchased by Cisco, so I guess I work there too. And I used to be a threat analyst at NASA for about 5 years, where I helped to build the Security Operations Center, and then initially as an analyst, and then moved into a role where I was trying to predict threats to the agency. And then I was a threat analyst at Mandiant. I took a year off of NASA and didn't plan to go back, but I worked at Mandiant for almost a year. So I'm going to be talking about some honeypots and how I organize them to get some actionable information from them. I only have a few honeypots that I'm working with for the moment, and there are more coming. But the ones I'll be talking about are an SSH one, and a malware honeypot, and one involving gas tanks, which is pretty cool, and SCADA honeypots. So the SSH one is, I've been actually using this one called Pyorre, which is a fork of Kippo. Kippo is a low interaction honeypot where people or attackers can connect in thinking they're SSHing into a Unix or Linux system. Kippo has some limitations that I didn't like, such as only 2 user accounts and password combinations are allowed. And to add more user accounts, you have to watch your auth logs and then get all those user passwords and add those as users to Kippo. There's also some other limitations I don't like. So the person who wrote Pyorre did a really good job of fixing some of the limitations. It writes 2 log files, which is a difference from Kippo. One of which is a JSON file, which is great for importing into certain databases, and also a log file. They both have slightly different information, which I make use of in my honeypot network that I'm building. Creates session files. This isn't new. This is what Kippo does as well. This means it basically records everything that a person who is SSH'd into the system records everything they did, and you can replay those files back using a Python script that's included. Just some administrative stuff. I set IP tables rule to send port 22 traffic to Pyorre, and I do my admin SSH account to a different port. People seem to like 2222. I just chose the next one up for some reason. This is just a view of what it looks like when you run the playlog Python script that will replay a session. You can just kind of see what an attacker is doing. In this case, they've logged in and they're doing a wget to this IP address, this file called linunv, and they're downloading it. You can make certain commands available to the attacker, or you can put fake commands in there. It's cool to have this, but it's not totally useful, especially if you have hundreds of attackers a day. You can see here they're trying to run the command, and then they're changing the permissions on the file, and then they try to run it again, but they're not able to because it's a sandboxed environment. But this can take you a while to get intelligence from that. If you want that IP address information, you've got to copy it and paste it into whatever your threat intel platform or research platform is. It can take a lot of work. And Dionea is another honeypot I'm using. It's meant to capture malware. It wants to get a copy of the malware on the system so that you can analyze it. It writes to a SQLite database as opposed to text files like the last honeypot. This is just a little viewer. You can see there are a lot of options. So this is still in progress. I'm actually working on getting the data I want out of Dionea in a way that I want it, so that it can be useful and actioned upon. But you can see there's a lot of stuff to work with. It saves malware into a folder, so you can just grab that malware. It's nice, unless you have 100 honeypots or 1,000 honeypots. It's a little bit more difficult, which I address. I'm also going to be talking about using Honeypot. That's one of the ones I'm using, which is a SCADA honeypot. It imitates industrial control systems. It's best not to install this on maybe the same server as your SSH honeypot, because it's supposed to be a hardware device of some sort, and I'll talk more about that soon. And then I'm using Gaspot, which this article by this paper by Trend Micro is pretty interesting, but it's about sensors inside gas tanks that are used to report the temperature, so you can connect in and issue a very small subset of commands to maybe fool it to think that it's too cool in there and have it heat up or something like that. That's the idea of it, at least. This is an Nmap scan of one of my honeypots that I'm using, and you can see that a lot of ports are open. I have FTP, it's just anonymous. You can connect in SSH, of course, and a bunch of other ones that are available for exploitation, and they all have their own different sandboxes on them, all configured in the different ways that the honeypots are configured, and it's all kind of a pain. So some of the obstacles that I'm encountering is, like I just mentioned, installation is a pain. They're all different. They write to different kind of log files, different places. They're open source projects in the majority of cases. So you have to learn each one and how to work with each one. You could get all your information from just one honeypot and just be done with that, but it's better to have more for more context. Dianed is really picky, doesn't like Ubuntu after 12.04, doesn't like 64-bit Ubuntu or 64-bit Linux. So it's just kind of a pain. So current honeypot networks, this one here is one that's actually was influential. I saw this and I was like, this is great. This is what I'm going to do with for a while. So I was playing with this one, and it's made by a guy named Jason Trost at ThreatStream, which is a company in the Bay Area of California. It's funny, I actually used to own the domain threatstream.com before they were a company, and I gave it up, which was dumb. Anyway, this honeypot shows you the main screen shows you a map, which everyone is probably familiar with, and the little attack stats down at the bottom. But if you go away from this page and come back, it's not persistent. Little dots showing you where the attacks came from go away, and you have to wait for new attacks to come in. Has other features such as you can deploy different kinds of sensors really easily by clicking on the deploy option up at the top, and you can choose what you want, what kind of honeypot, or if you want a snort or a Suricata IDS. And it gives you some stats, and it's being improved upon, so it's getting better and better. But for example, this top IP address, I could copy that and paste it into whatever I use for research, see why I'm getting so many attacks from there. It's giving me a summary, but it's not giving me actually intelligent information as of yet. If I want intelligent information, I've got to use my brain first, or use all the analysts that are working with me. They have maps. That's the most common feature. Seems to be the purpose of honeypots, which I actually find to be mostly useless. They look really fantastic, but what do you do with it? So what if there's a lot of little dots coming from China or wherever? This one's cool though, the iPew. If you have, you can check this out. It actually plays little pew sounds as it shoots. Pretty cool. I was going to set that up in my honeypot, but I decided I don't have time. So we want more than this. We want to be like this guy. Like, this is Brian Krebs. He's an author and a blogger in America. Hopefully you probably know about him. He's often the first place that people go for information, because he's so close to the data, to the attacking information. Like, he focuses mainly on ATM skimming and point-of-sale malware, but he also did, I hopefully have my facts right, but he learned Russian, infiltrated carding forums, and disrupted them by reporting on them, and of course got death threats, and he gets 911 calls to his house, so the SWAT team shows up as practical jokes because of it. But he works really hard to get close to the source of information so that the rest of us in the InfoSec community can be on top of things at least a little bit. We're still a little bit behind though. I want to be like this character. I don't know if you have this show or if you've seen it. It's called Mr. Robot. It's an awesome show. This actor plays a hacker, and it's one of the better versions of TP hacking that I've seen. But you want to know what the hacker is thinking. We want to be like these guys. We want to know what they're thinking. It's kind of funny. These are wanted in the U.S. These people for state-sponsored attacks. It's kind of funny. They'll never get apprehended, But we want to know what it is they're going after. What kind of things do they want? The problems that we have are we work in the past. So I deal with a lot of reports from the government, at least I have, and I still do in my current position, but in previous position I would deal with open reports and also more secret and depending on clearance levels, but it's all the same, really, same data, different format. And the thing about it that's really annoying is I've received reports like this with Excel spreadsheets full of thousands of domains, tens of thousands of domains, and it's like they aren't vetted at all. I've gone through them and seen legitimate domains such as Microsoft.com or Google.com. It's almost as if they are just capturing something on their sensors that they have in their places and just blanket delivering you a whole bunch of crap that you can't, you have to go vet it yourself, and you're assuming these reports are designed so that you don't have to work too hard, but you do. We also work with reports. This is a good report on APT1, but APT1, this report, well, that's what they're calling it, Mandiant was. This report, it came out after it was already, in systems doing things for quite a long time. So it's old data, but as a threat analyst or as someone who works in that kind of position, you're reading these reports and you're like, oh, I don't have all these domains blocked, or I don't have information on these domains, so I'm going to put them in my sinkhole or whatever. It's way late, probably useless, but that's what we have to work off of. And another report, just, this was about Zeus Zbot, but it's late when you get it, even if it's on the day that you get it. This is marketing stuff. A lot of times I read through reports and I'm like, oh, this is really interesting. I haven't heard about this, or this is a new take on this malware variant. And then I get to the end and it's like, install our product if you want to have it work for you. Have no malware on your system. And I realize I've wasted like an hour of my life. So there's other ways, there's other feeds you can do, like this is just a Google search for a hacker, which is more entertaining than anything else. I mean, you get things like this, which is a terrible show, but but it's whatever. So I also have this is just a screenshot of my RSS feed. All this data, it's very useful. There are some blogs I follow that are on point. They're like, they know they have information as it comes out, but it's still too late in the case of most agencies, most organizations. What we actually want is to have actionable intelligence, and we want to predict the future just a bit, at least, or as much as you can. You want to know what's going to happen before it's going to happen based on events, current events, based on what kind of industry you work in. There's management issues with these honeypots. Honeypots, by the way, are a way to get closer to the attacker and get some actual intelligence that you can use before it becomes a threat inside your environment. Problem is, though, this data is available on all your honeypots. Say you have 1,000 honeypots out there, so that's great. You've got a lot of stuff. They're all over the world. It's all your log files and all your databases. Malware is in there too. You can get all that stuff, but you can just go SCP it, like copy it over from these systems, and then start analyzing it, and then take precautions. But that's going to take a long time. You need a lot of people doing a lot of things, a lot of research. It's better to do this programmatically if you can. So I'm working to try to change the way that works. The structure of the honeypot system I'm building, kind of like this. My server actually is in Virginia right now that I have. It's on AWS. I actually keep rewiping it and redoing it, so you'll see some changes as I'm moving forward. This is the active work in progress. And when I get to the end, you'll see that it's available to everyone. But I have various honeypots all over the world. I divide them up. I have compot and gaspot usually running separate from the SSH and Dianea honeypots. I'm also using GlassTop F. I haven't mentioned that one yet, but I'm using a bunch of other honeypots I'm exploring. But you want to separate them, like compot and gaspot should be on physical systems, best to do on a Raspberry Pi or something like that because it's cheap. You could theoretically leave it places like hotels, if you can find a secret place to stash it. I wouldn't recommend that. But you can do whatever you want within reason. And SSH and Dianea, I have those running in just an Amazon web servers. I also have them running in VPSs. I've got one physical system at home that runs it. But it's good to divide them up, because someone connecting into Compot is going to be able to easily figure out that it's, if they think they're connecting to a internet-connected heater or centrifuge, they won't, they'll be a little suspicious if it's on Amazon Web Services, you know. So I have analysis scripts running on these honeypots. I have very minimal, I only have 2 running on them at the moment. I want it to be, I want the activity of the processor focused on these honeypots and giving the attackers what they deserve, you know, what they need. I have Logstash running, which actually takes up a lot of processing power, but it's what I'm using to, I'm doing some further processing there. And it sends stuff over S-tunnel, which goes to the server, which is listening on S-tunnel. I have it listening on 2 ports, 1 port for Logstash stuff, for Elasticsearch database, and then 1 for files being transferred. And then I have Redis, which is, I'm just using as a data broker, so all the data just gets pushed in, and Redis kind of hands it over to Logstash again, and I have more further filtering on the Logstash instance to send it where it needs to go. So then I have, depending on where things are being sent, I have analysis scripts. I have multiple ones running to do various things with a different kind of honeypots. And then depending on what I do with each, I either send stuff to a MongoDB for intelligence, or Elasticsearch for hopefully pretty dashboard. You can also get some intel from that too. And I have Kibana running, looking at Elasticsearch, which is like a free version of Splunk. Elasticsearch, Kibana, and Logstash are a whole little package deal. You can run them separately, but they work well together. I'm using Flask, which is a Python framework for web development. It's kind of very basic and simple to present my results. And it's new to me, so when you see what it looks like, you'll see that it's new to me. My goals were easy installation, secure communication using S-tunnel. I don't want any attackers attacking our honeypots knowing there's something else going out. I mean, of course, if they get out of a honeypot, there are ways. There was something about getting out of SSH honeypots that are running with their systems running Logstash and actually infiltrating, getting into the Elasticsearch database. But I'm not talking about that. So. I want automatic and central analysis, and I don't want it to be done by a person. I mean, for the most part, I'd like it to be done by computers. So the easy installation, I have just this one setup script which you run on the server, and when you run it, it creates this, it does its thing, installing everything, and then it creates a tarball that you would copy over to the clients, and I can improve upon this. I can follow the pattern of Modern Honey Network. I didn't want to copy him exactly, but I wanted to build my own thing, and then later on I'll move it over to something like what he's doing. But for now, it's you copy this over to the systems, and it takes care of everything you need. So on the clients, I have these 2 scripts running. I've got get malware info. This just takes the SHA-256 hashes from any malware that is found from Dionea or SSH or anything really that gets pulled down onto the system by an attacker. And it just saves the information to a file which Logstash processes and sends over to the server. And then I have read TTY. I mean, it's cool to be able to play that little Python script and watch it. You can show people what people are typing. You can speed it up, slow it down. But I have a script that automatically just saves them to text files, so you can do further analysis on those text files, and maybe you don't have to sit there reading them all the time. This is just what it looks like. Flat text file. This is that same thing you were seeing before. This isn't a progression. This is just it just takes a screenshot, not a screenshot, but a text shot or whatever you call it. And then we can get information. We can pull that IP out by doing some probably natural language processing with Python or something like that. Looking at the IP actually will show you just a little diversion. Looking at this in another way, I can see that IP belongs to ISP in China. Those are the AS that it belongs to. And I can see that there's some files associated with this IP in the past. So server actions, I've kind of gone over this already, but S-tunnel sends to Logstash. That's the logo for Logstash, which is awesome. And this is a little piece of my filter file that takes all the data and filters it don't have to try to figure it out because you can just look through my code. The files from the honeypots, this is actually on the server. All the files, they get pushed into this folder, opt files incoming. And I have the compot log, I have a cowrie, JSON, and log file. And then I have malware from honeypots. That's the 256. I think I actually just go right over those again. But no, actually, so in the analysis folder, this is opt analysis, I have all these Python scripts that I've written, and I have some API keys. Currently, I'm only using 2 third-party tools. I mean, I work at OpenDNS, so it's weird to say a third party because but Investigate is it's a tool that we have at OpenDNS. So I'm using that, and I use VirusTotal. I use their API to get some information, but there's more stuff coming that I'm working on. I want to make it so it's free. There's some things that cost money, and I want to make it so you can get analysis for free, basically. The VirusTotal API, it reads those hashes and sends them to VirusTotal, gets back the results, and any results it gets, it pushes them onto the MongoDB for analysis. The compot reader reads the compot logs, sends information off to OpenDNS Investigate, gets information on that. I'm only getting the most minimal amount of data right now, just some whois information, more of a proof of concept, but I can get more information. I can get cool things like co-occurring domains or IP addresses that are contacted at the exact same time that domain's typically contacted. There's just lots of cool stuff. I have a cowrie log analysis, and then I have a gaspot reader, which just reads those logs and looks up information in various sites. Extra special things, well, I kind of covered the VirusTotal API and the OpenDNS Investigate. Actually, the VirusTotal, you can do that for free, but you can only do 4 calls per minute. If you pay, you can do almost unlimited. I don't think we've hit the limit where I'm working, and we do it a lot. I'm working on being able to send your stuff, your malware, and your information to your own personal Cuckoo sandbox. Cuckoo is a malware analysis sandbox, which is awesome and open source. And so I think if you're working in an environment where you need to keep your stuff secret, especially if you have your honeypots in your own IP space, so you can catch stuff destined for your industry, it's nice to be able to keep that stuff private. But you can also send it out to the public. There's a public one called malware, malwr.com, which is basically a Cuckoo sandbox you can send to. You can also send for private analysis to them as well. Just looking at the investigate data further, this is kind of what we're seeing. This is an IP address that someone who connected in called out to. They said, wget this, or what, I don't remember what they did. And I just got some the AS information, and this is really, really basic, the creation data, that IP. I can get a lot more than that, but just to show you what it looked like. And looking at it in Investigate, you can see there's the same information, it's just a little bit prettier. But I don't have to copy that and paste it in and go search it out. Looking at, this is another IP, this is an IP connecting in right here. You can see their username and their password. It's cool just to see it, but it's not yet providing information that's totally useful. I have been able to find patterns with certain passwords that are used that have associated activities with activities I've seen in the past, which is kind of really interesting. Or as also, I've seen passwords that are associated with certain kind of botnets that are constantly trying to connect in. But I can see there's some other information. I can see what other IPs in other ranges that have domains running on them, and I can do some more, pull more data from that. So you need to get visual stuff still. Management loves to have a dashboard. I actually searched for ugliest dashboard. This is pretty ugly. I don't know if who's from the US, or who's ever been with the US government, but the US government is really good at making ugly dashboards. I think this is from CERT. My dashboard isn't that pretty either, but it's still work in progress. You should be able to search. So you also need the threat map. Management really needs this threat map. It's very important to them. They need to see what countries are attacking. They want to put it on the wall. So I have a threat map. This is kind of what it looks like. My my preliminary dashboard. You can see I've got a count of SSH connections at this time. I took the screenshot, and gas pot connections, con pot. Got this kind of pie chart. I've got more information. I've actually added quite a bit more since then. You can see where they're coming from. This still isn't the coolest stuff, in my opinion. This is handy, but it's really mostly useless to me. I can search in a Splunk-like interface that's free because it's Kibana. I search for gas pot. I can see whenever I filter in Logstash, it's all depending on how you filter the Logstash. And this is kind of I'm going to go over this in just a second, but this is a quick view of just the basic intel, the way it looks. You can see connections, and so far it's really just who is information. That's all I've added, but of course I can add more. And I can get the information from the GET requests. I can see kind of in like a follow TCP streams format, like you do with Wireshark, if you ever work with Wireshark. You can kind of see what they're getting, and so you can analyze this file. In progress are still the Diana reader, where I'm trying to optimize that, so it's a lot nicer. Passive DNS, there's actually a great free passive DNS tool that you can run on your system, and it saves stuff to a text file or to a database. Although you don't necessarily need it, because you have someone connecting in that call out, you're going to have that information if you're doing various kinds of intelligence gathering. Malware analysis, that's website, malware.com or Cuckoo Sandbox. The ability to download malware, I haven't done that yet. It's just because I've been working on other things. But you should be able to download all malware from all the honeypots and know where it came from, which honeypot. So you can analyze why it's on that honeypot, not on this other one, why it's on this Windows honeypot, not this Linux one, or, well, that makes sense. But you should be able to get all that stuff from the server, not from the honeypots. You should never have to go into the honeypots at all, except to make sure that they haven't run out of disk space or something like that. And this is the biggest thing I'm working on right now, which is doing Docker images, because I'm trying to compartmentalize the installations. I wanted to make it easier than it already is. I want it to be, you should be able to turn them on and off at a button press. So I'm working towards that. And just maybe replay the log, CSI cyber style. In this episode, they had green code. They're looking for red code. So, and there's the red code, so that means they found the bad malware. So it's not too hard to implement, just, Anyway, this is what I'm more excited about, is real analysis, but it requires a lot of processing, brain processing before you can do the Python processing. I love this GIF. This is just taken into Excel, the data. I assume it's playing. Well, it doesn't, you don't really need to see the whole thing. But just zooming down, you can kind of see this is a pivot table, basically. You can see who's the biggest offender. I think it's China, but whatever. 534 at the time I took this. Looking at the next, you can see, you can make pie charts, by ASN, who's the biggest offender, and I think that's Charter Communications. So, this stuff can be generated dynamically for your dashboard. It's very useful to see. The best thing about analyzing data like this and getting pictures like this is if you happen to install your honeypots in your IP space and you work in aerospace or something like that, you can, and you're watching current events, maybe there's a new aerospace thing out there, and all of a sudden a bunch of new attacks come from a certain country, then you can use that in your future threat analysis and prepare for things in the future. That's what I'm going for here. And this is even like more the same. It's a time series analysis. If you can correlate times with events, current events, and your industry, then you are way ahead of the game than most people. You're not looking at old data. You're looking at fresh data, and you're actually able to look into the future and see what's about to happen. This is just a quick little video of analysis script I wrote just to show some different other things you can do. I mean, I'm programmatically doing those Excel spreadsheets basically instead of doing them manually. That was a unique IPs. You can get the summary data. This is like the pivot table. There's the top IP, the count right there, 534 of that data set. This should be, you can set this to auto-generate basically. You can also plot it, so you can create plots, ugly plots in this case, but there's ways to make it prettier. This is just a time series analysis, so you can see what's happening at certain times. So yeah, like I've mentioned, I'm interested in attack times based on location. Like if you have a honeypot, and I have one, the most active one is in Brazil right now. I don't know why. I need to figure out why it's more active than other ones. And I want to know why it's busy, or why any honeypot is busy based on what's happening in the world. So I want to know what kind of malware I have based on the type of honeypot and why based on the time. Data based on current events. I keep reiterating that, but I think it's very important. And I want lots more data. So I'm just installing more and more honeypots. My current modifications beyond that I've talked about here is I just doing a lot of programming, reading books like Practical Data Analysis, compartmentalizing these honeypots so they're separate and more unique. You have to go into some of these and configure them for the environment they're in. Like gas pot has to be, you need to say it's a certain gas station or a certain kind of gas station, and if you say it's Exxon and Exxon doesn't exist there, then someone's going to catch on if it's smart. I'm adding just as of yesterday the ability to differentiate the clients, because I think that's a really big feature that should be there. Organizing, it's kind of redundant. Pattern recognition, just looking for patterns, big and small stuff with that data. So it's kind of a closer look. On the left, I'm SSHing into one of my honeypots, and on the right is the dashboard live running, and I'm typing whatever password I type, and you can see here that it pops up with the map, and then in a second pops up with the one SSH connection. So that's cool. Then I'm going to telnet to the system, to the port that's running for GasPot, and this one's actually kind of interesting. It pops up, you see there's two connections, but I didn't do two, I just did one. I just telnetted it in, disconnected, counts as one connection, but down at the bottom, it just was a coincidence. Someone from South America happened to try it right at the exact same time. It's pretty cool. I thought like I did it wrong or something. And this is kind of what it looks like. I showed you some screenshots, but just to walk through real quick. You can see these are the follow TCP stream view of what they're doing when they SSH. This is from SSH only. A lot of, you can just see what they're getting. A lot of spam related stuff, which is weird. Successful SSH connections, and you can see you can do some follow patterns on the passwords based on location. Like that one's really interesting, but I found some stuff about that, but I'm moving on. You can get the Excel spread, get a CSV file, so you can be the data sender. I wouldn't recommend doing this blanket sending it to people like everyone does nowadays. Don't be a part of the problem. But if you want to provide good stuff to people, you can. Here's call outs to IP addresses, and it's not very much stuff because, like I said, I wipe it and reload it all the time as I improve the system. Malware found on VirusTotal, this gives you the information found based on malware. I'm adding in the ability to send stuff to VirusTotal. All of that's not always the best idea if you want to keep something private, but you can see what it is. A lot of the stuff, because this is a Linux system, is like DDoS software that they're just trying to take over a Linux system. But it's cool to see that. And the system is in AWS, this specific honeypot. So that sent that information. If I put it in my organization, maybe I'll see some other kind of malware because they want something else. And Compot and GasPot. GasPot, it's just showing, these are just connection attempts right here, but there's some actual commands typed. There's only about, if you download the manual, there's not very many commands to type. It's a very easy thing to play with. And yeah, so that's it. If you want to get a copy of it, feel free to download it, play with it, do whatever you want with it. Totally open source. I have Investigate, unfortunately, is a paid thing, but I'm adding as many things as I can to replicate that. I mean, while I work there, I OpenDNS, you should always be able to get this stuff without paying for it. I mean, paying is great because you can get a better quality of service, but I want you to be able to put this in your environment and get the data that you need to do your job and make your environment safer. So that's it. Does anyone have any questions?
Thanks, Josh.
All right.
Yeah, the Intelligent Honeynet project is available on GitHub.
Yeah.
Uses Python 2.7, 3.0.
Both, but this one's 2.7. Yeah.
And you're happy to accept pull requests, I guess.
Oh, yeah.
So, are there any questions?
Here's a question.
We have plenty of time for questions.
Martin, nice to meet you.
Hi.
One of the problems that we normally run into problems, oh, by the way, we're from Trend Micro,
okay.
is deploying honeypots. You mentioned Amazon Cloud Service as a space where you're going to have some of your honeypots running. I always hear from my researchers, it works for a week or for two, but then Amazon comes back and says, take that out of our network. I hear that from multiple ISPs. How are you going to deal with that?
Well, you can specify, you can ask Amazon or tell them that you have a network that you are doing this. That's actually, for these AWS instances, I was using my company's account, and we have a certain network that they will leave us alone no matter what they see, which is nice. But then I also have, beyond that, I have VPSs, like DigitalOcean, $5 a system, super cheap. They don't care what's on the system, and I can tell because I see phishing and malware on DigitalOcean all the time. But AWS, you can have that if you want it. It doesn't cost anything too. They just will leave you be. Well, it doesn't cost anything more. AWS is not recommended actually. It's expensive.
Further questions? Don't worry, there's plenty of time. No one?
Well, feel free to come talk to me if you want, or if you have any questions about it, other stuff. I like talking about security operations centers and intrusion detection, things like that.
So you'll be around?
Oh, I'm here,
and
yeah.
At the speakers dinner tonight?
Yeah, I'll be here for till tomorrow or the end. So.
Okay, so
Cool.
If you come up with questions, oh, there's a question.
While you're also analyzing some data, there were some data which is analyzing you that they were like failing at commands or some stuff like this, or strange behavior which will see what the fuck they're doing.
Oh wait, so can you say that again?
What are some behavior of some attackers where you thought about what the fuck are they doing with on the machine?
Well, interesting. When you watch stuff come, well, sometimes it's just bots, but I've actually seen someone who has gotten into the system and they are typing away, and it's almost like they have a script, and that's probably pretty likely, like state-sponsored actors. The low level, say, let's use China as an example. Low level workers are just usually not the ones who are the super technical. They're just copying and pasting commands or just typing what they see. They go through a list, and I've watched them do that. It's really interesting. And it gives you an idea of the structure that they're working with. The people who are writing the malware are probably not, SSHing in, or people writing the SSH bots are not even SSHing in. So.